Hello and namaste to everyone. This is Name-Shalu Singh from Department of Physiotherapy and Diagnosis from Jayoti Vidyapeeth Women's University. Today, I'll be talking about respiratory regulation of pH. So, in our past lectures, we got to know about acid, bases, buffers. Then we talked about buffers for of the body fluid. So, our body basically uses three mechanisms for the regulation of pH. So, there is first of all there is first line of defense which is done by blood buffers. Secondly, there is a second line of defense, which is respiratory regulation, which we will be getting into right now. And then there is third line of defense, which is renal regulation, right? So blood buffers, there are three types of blood buffers, which we read: bicarbonate buffer, phosphate buffer, and your protein buffers. So bicarbonate buffers and protein buffers, we have already read that these are very important. But phosphate buffer, it matlab, it is there, it has very less of use, because it is in our body, it contributes very less. So which is of very less use, but still protein buffer and your bicarbonate buffer, they are of utmost importance. So also in protein buffers, we have also read about relative capacity of a buffer system. And further, today we'll be talking about the second line of defense. And in this second line of defense, we'll be talking about respiratory regulation of pH. So respiratory regulation of pH, obviously respiration, it is attributed to your lungs always. So it is achieved by changing the PCO2, that is pressure of carbon dioxide or carbonic acid, which was the denominator in the equation which I've already told you. So the carbon dioxide, it diffuses from cells into extracellular fluids, and it reaches the lungs through blood. So the rate of respiration or the rate of elimination of carbon dioxide, it is controlled by your chemoreceptors in the respiratory center, which is sensitive to changes in the pH of blood. And when there is a fall in pH of plasma, which is in condition of acidosis. So I've already told you that the normal pH of plasma is basically 7.4. The range was between 7.38 to 7.42. So in any condition, when pH goes below 7.38, it is the condition of acidosis. So the respiratory rate, it is stimulated and it results in hyperventilation, and this would eliminate more carbon dioxide and thus lowering the level of H2CO3. So however, this cannot continue for long. So the respiratory system responds to any change in pH and immediately, but it cannot proceed to completion. Now, what is here in a respiratory regulation of pH? Two of the components are acting very crucial role. First one is your lung, which is the exchanger of hydrogen, carbon dioxide, and your oxygen, right? We are taking in oxygen and giving out carbon dioxide. Second, it takes place at the level of your hemoglobin, right? So hemoglobin, action at the level of hemoglobin is very important here. So the next point here that we have to study is action of hemoglobin. So hemoglobin, it serves to transport the carbon dioxide formed in the tissues with a minimum change in pH. So side by side, it serves to generate bicarbonate or alkali reserve by the activity of carbonic anhydrase system. So carbonic anhydrase will be the enzyme which will be used. So here we can come across various equations like carbon dioxide when it combines with water, And in the presence of carbonic anhydrase, it will give H2CO3. Next, H2CO, it will break down into HCO3 minus plus H plus, right? Now, H plus HB, it will give HHB. So the reverse occurs in lungs during oxygenation and elimination of oxygen. And when blood reaches the lungs, the bicarbonate will re-enter the erythrocytes by the reversible of chloride shift. Chloride shift is very important, which you will also read in your vitamins and minerals in your when you'll read about chlorine, there will be chloride shift. So it combines with hydrogen liberated on oxygen of hemoglobin to form carbonic acid and dissociates into carbon dioxide and water. So carbon dioxide is thus eliminated by the lungs. So later, HHP plus oxygen will give HbO2 plus hydrogen, and HCO3 minus plus H plus will give H2CO3, and H2CO3 will further give water and carbon dioxide. Now this carbon dioxide will be eliminated by your lungs. So the activity of carbonic hydrase, or we can say carbonate dehydratase, it increases in case of acidosis and decreases with decrease in hydrogen ion concentrations. And now the respiratory system, it contributes to your balance of acids and bases in the body by regulating blood levels of carbonic acid and carbon dioxide in the blood readily, and it reacts with water to form carbonic acid at the level of carbon dioxide and carbonic acid in the blood, which are in equilibrium. So when carbon dioxide levels in blood rises, so as it does when you hold your breath, so the excess of carbon dioxide, it will reach with water to form additional carbonic acid, lowering pH and increase the rate or depth, increase the rate. It will basically increase the rate or depth of respiration, which you might feel the urge to do after like holding your breath. When you hold your breath for long and you feel the urge to breathe, because there is the amount of oxygen level it lowers in your body, so it allows you to exhale more of carbon dioxide. The loss of carbon dioxide from the body reduces blood levels of carbonic acid and thereby adjusts the pH upward towards the normal levels. As you might have surmised, this process also works in opposite direction, and excessive deep and rapid breathing. If you keep breathing faster and take deep breaths, which is also called in medical terms, we call it as hyperventilation, like faster breathing, and it gets rid of the blood of carbon dioxide. So the carbon dioxide, if you breathe faster, that means you're taking more of oxygen in and giving out less of getting rid of all your carbon dioxide. So it reduces the level of your carbonic acid and make the blood too alkaline. It will make your blood very much alkaline, because carbon dioxide, it is responsible for the acidity of your blood. So this brief alkalosis, it can be remedied by deep breathing air that has been exhaled into a paper bag, right? So rebreathing exhale here will rapidly bring blood pH down towards normal. Now, the chemical reactions that regulate the level of carbon dioxide and carbonic acid, they occur in lungs when blood travels from lungs pulmonary capillaries, and further, these minor adjustments in breathing, they are usually sufficient to adjust the pH of blood by changing how much carbon dioxide is exhaled. So, in fact, the doubling the respiratory rate for less than 1 minute and removing extra carbon dioxide, it would increase the blood pH by 0.2. So it is very important to know that doubling the respiratory rate for less than 1 minute, it will remove extra carbon dioxide and it will increase your pH by 0.2. That means the blood will get alkaline. So by increasing the pH, it will be alkaline. So this situation is common if you are mostly when we do hyperventilation, when do we do heavy breathing? Mostly during our cases of exercise, of if we come from running, if we climb stairs, or we do something that takes a lot of energy. So these works will keep us to hyperventilation. So, to keep up the necessary energy production, you would produce excess of carbon dioxide. So, excess of carbon dioxide meaning there will be lactic acid production, which, if exercising beyond your aerobic threshold. So, muscles they'll start producing lactic acid, and you may also encounter, or you may also come across cramps if there will be a lot of lactic acid accumulation and within your muscles. So, in order to balance the increased acid production, the respiratory rate goes up to remove the carbon dioxide. So, this helps to keep you from developing acidosis or acidic condition. So, the body regulates the respiratory rate by the use of further chemoreceptors, which primarily use carbon dioxide as signal, and peripheral blood sensors. They are found in the bloods of aorta and your carotid arteries. Now, these sensors they signal the blood brain to provide immediate adjustments to the respiratory rate, and if carbon dioxide levels rise or they fall. So, yet other sensors they are found in brain itself. Now, the change in pH of CSF, cerebrospinal fluid, they affect the respiratory center in your medulla oblongata, and which can directly modulate breathing rate and to bring the pH back to its normal range. So, hypercapnia or abnormal elevated blood levels of carbon dioxide. So, matlab, hypercapnia is the term which can be used for elevated levels of carbon dioxide, and it occurs in any situation which will impair your respiratory functions, such as including the conditions of pneumonia, right, where you have difficulty in breathing and your respiratory functions are obviously impaired. So, in your congestive heart failure, where you have heavy breathing conditions, so reduced breathing, so means the heavy breathing was hyperventilation. So here, in case of reduced breathing, this is the condition of hypoventilation due to drugs such as hypoventilation cases are encountered during cases of morphine, barbiturates, or ethanol, or even just holding one's breath. If you hold someone's breath for too long, it will lead to hypoventilation, or and it will further result into hypercapnia. If you hold someone's breath, the oxygen is not coming out, neither you're taking in oxygen in order to compensate the carbon dioxide. So in a way, your carbon dioxide levels are increasing in your blood, so it is leading to acidosis. Carbon dioxide is responsible for the acidic condition of your body. So it is the condition of hypercapnia, or the other condition is your hypocapnia, or which is the reverse of hypercapnia, obviously, which is abnormally low levels of carbon dioxide, and they occur within any cause of hyperventilation, and that drives off the carbon dioxide, and that it may occur in cases of your salicylate toxicity, elevated room temperatures, obviously, and in cases of fever, and or in cases of hysteria. If the most common is your fever, which you have, or in a room temperature elevation, if in the summers also, or in case of fevers also, you would have seen that the person starts to breathe heavily, like they get heavy hyperventilation. In that case, there is a carbon dioxide removal from your body. This is how the respiratory system within our body, it is regulating the amount of pH within our body by exchanging the amount of oxygen and carbon dioxide, whether between lungs and tissues, or between mainly between the most common example that we give is between lungs and your hemoglobin, right? So hemoglobin is also trying to maintain the pH by carrying the amount of oxygen, or carrying the oxygen from one part of our body to another part. So this was it, and this was all about respiratory regulation of pH. Later, we'll be talking about renal regulation of pH. Okay, so which will be your third line of defense. So this one was your second line of defense. Later, we'll be talking about your third line of defense. So until then, do read about your buffers, your do read about your first line of defense, and do read about your third line of defense. So until then, I'll take a leave. And if you have any issues regarding your respiratory regulation of pH, you may always contact me. And thank you so much and take care.